In this video, I'm going to take a look at a pretty fun problem. We are multiplying some rational expressions. So when we have rational expressions and we're multiplying, we got to just keep in the back of our minds some values that the answer cannot be, meaning like x cannot equal something. So what can't happen is we can't zero out the denominator. So right now I see that x minus 4, so I'm just going to go ahead and just write that down. X minus 4 equals 0. Add 4, add 4. So right now we know x cannot equal positive 4, so there's something to keep in mind. We always want to identify those spots where x cannot exist, and that's at 4, because 4 minus 4 is 0, so that's going to zero out. Now right here, just glancing at that, I don't know what that is. So here's what we have to do now. Here's our next step, is we want to factor everything, because at the end, after we factor everything, here's the process that we want to take. So let's say I had like just something like this. Let's say like 2 over 5 times like 1 over 4. Let's say we're multiplying just two fractions. What we would do, there's a couple different routes you could take, but what we would do is you would say, well, I have 2 and 4. Those can actually simplify. 2 goes into 2 one time, 2 goes into 4 twice, and then I would just multiply across the top. 1 over 5 times 2 is 10, or you would multiply 2 times 1 on the top, which is 2, 5 times 4, which is 20, and then you would simplify like that. I would go this route though, just because that could get a little messy if you're trying to simplify, but I would try to simplify at the beginning. But those are two perfectly fine routes. We want to take the same approach with rational expressions. So we want to factor everything. And then, since we are multiplying, we can just see, does anything cancel out? Does anything simplify down? Meaning, do we have the same expression on the top as the bottom? So let's check this out. So x squared minus 9 is a difference of two squares, because x squared is a perfect square, 9 is a perfect square, so difference of two squares. That's going to be x minus 3 times x plus 3, just knowing difference of two squares there. The bottom here is x minus 4. Not going to touch that just yet. And this is multiplication, so we don't have to like do anything fancy, just multiplying everything together. So on the top here, this is another difference of two squares, x squared minus 16. X squared is a perfect square. 16 is a perfect square. So x minus 4 times x plus 4. Then on the bottom we have a trinomial, quadratic here. So I have to factor using a different method. I have to think of two numbers that multiply to 6 and add up to 5. So two numbers that multiply to 6, add up to 5 is going to be 3 times 2, because 3 times 2 is 6. 3 plus 2 is 5. Those are my factors. So x plus 3 and x plus 2. So what that also means is, since I have these values, remember, going back to the domain, remember how I said I couldn't just look at that and determine what x is there? I had to factor it. Now that I have that, we do want to establish what x cannot equal. So I'm going to set both of those factors equal to 0. So x cannot equal negative 3. X cannot equal negative 2. So we've just established a couple of values that x cannot equal. All right, so now what do we do? Well, like I was saying over here, when we had something like this, where we had 2 over 5 times 1 over 4, the thought process is, well, I have 2 and 4. That simplifies down to 1/2. What can happen here? I have an x minus 3 on the top of my fraction. Just look at the top and then look at the bottom. Do I have an x minus 3 on the bottom anywhere? No, I do not have an x minus 3. Okay, so x minus 3 is going to stay there. Looking at the x plus 3, do I have an x plus 3 anywhere on the bottom? Yes, I have it right here. So since I have the same factor, that's the same thing as having 2 over 5 times 1 over 2, and then we'd say, oh, 2's cancel, because 2 over 2 is 1, same thing. So I'm going to say x plus 3's cancel out, simplify down to 1, so those are out of the picture. That's nice. Next, I have an x minus 4. Do I have an x minus 4 anywhere on the bottom? Yes. Same thing, x minus 4. Notice how I put parentheses around this? So let me just go back, or I don't even have to go back. So right here, see how it's just x minus 4? I just threw parentheses around that, so don't like get confused, like, wait, where are those parentheses coming from? You can just put parentheses around this and it's fine. So this is x minus 4, x minus 4. Those are going to cancel out. Next is an x plus 4. Do I have anything that's going to simplify out with the x plus 4? No, I don't. So now it's just an exercise of multiplying across the top, multiplying across the bottom. So on the top, I have x minus 3 times x plus 4 divided by x plus 2. And you could leave it like that or put the parentheses. It doesn't matter. But then that would be our answer. We can't do anything else. Don't multiply this all out. Just leave it like this. And that's it. Nothing else cancels. Nothing else to do there. So pretty fun problem. I like this. There's a lot of factoring. Pretty cool simplifications there. But just knowing your factoring rules will make that process that much easier. And then just understanding that anything can simplify with anywhere. A lot of people actually, now that I'm thinking of it, a lot of people like think if I had, let's say, an x minus 3 and an x minus 3 here times like 1 over x plus 2 or something like that. A lot of people just don't like catch this, that x minus 3's will cancel in this scenario because they're both on top and bottom. Like a lot of people just think that this is like cross cancellation only, where you could only cancel from the term to term. But there is scenarios where we could cancel out, like when you have two trinomials and one of them are the same factor, when you factor both and then one of them turns out to be the same, like those types of scenarios you can cancel. So just keep that in mind, that just because they're on the same part of the expression, the rational expression, doesn't mean that they can't cancel. They can. If they're the same, cancel them out. All right, so there it is.